Hello, 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 Cheers Kevin here, and welcome back to another episode of Minecraft Agoraphobia. By the way, we're still running Minecraft. Let me switch over to it. Minecraft. It's here. It's pretty Minecrafty, but really, we're working on trying to figure out Lua and why it is weird. So let me bring us back over there. Sorry. My mouse is getting all sorts of stuck. We're trying to figure out Lua. I'm trying to mess around with various things. I'm trying to clean up the code that we wrote last time. Let me go ahead and go here and delete that. I'm starting to try and modify our Android file. So I've moved this Android file, which has our test function and our Android thing and our test of the Android thing all in the same file. And I want to split this up so that it's a little bit cleaner. And what I want to do that is I want to go into test. I want to have Android yeah, I guess we're just going to have to delete this. We're going to have Android test. I want to separate the test code and the Android code. So I'm going to go ahead and copy these lines, which I'm not happy about having the duplication, but we're just going to go with that. Test is going to equal that. We'll say local test equals that. This is a library that we wrote to run tests, which is pretty cool. Hooray for us. Let's go ahead and grab the actual test that we ran as well. There's our test. Test goes down in here. So we can go ahead and close this up. We have now split up some content because we're basically building ourselves a library that's going to allow us to manipulate the robot in classier ways. So now the Android.lua can have its job be about, well, I suppose we can copy this fake. No, we'll just delete that. This is in theory what we want Android to be able to do. Robot should not go in here. This is our Android library right now. This is all it's able to do. Android.move right now just calls robot.forward. Cool. So that's what that does because we're using test to drive how it works. Here is our Android test. And that is we define a function called test, which will print out a check mark if a test passes and print out an X if the test fails. Let's go ahead and see what happens. Well, the test fails because we've broken stuff. The Android test attempt to index a new value, global robot, because robot does not exist. So let's go ahead and define it. Robot equals an empty object. And attempt to index the global Android. Android does not exist either. Well, Android, we want to test the thing that we just included here. So we have to find a way to get Android. So we'll say local Android equals require Android. Now this, I suspect, is not going to work. Yeah, it can't find the module Android. We need to figure out how this whole require system works. Which is important, because when we actually start using our Android file, let's say that we had some cool, get water, I don't know, however we're going to name these files, get water.lua, we would eventually say something like require, local Android equals require Android. And then we'd be like, Android.move, forward, left, forward, or whatever. That would be eventually how we would go about writing our script. So we want to make sure this whole require syntax works. Now, this is a case where basically we are deliberately breaking our tests so that we have a reason to fix our code, which is the kind of ultimate strategy of test-driven development. So we're still doing some TDD here. Okay, so package is not found, and that's fine. Let's go ahead and let's see. Here we go. Packages, creating modules. This is a tutorial about modules. Let's go to the full tutorial. Okay, nope, this is not helpful. Creating modules. This is how we go about creating modules. The file simply needs to return a thing. So for one, our Android file doesn't return a thing. Let's make it return a thing. Local Android equals this. Android.move is that. Return Android. There we go. Now our Android file is a valid module that we should, in theory, be able to require. Let's go over to our test and see if that's the case. It's still angry. And it's angry for the exact same reason. It's angry because it still can't find the file. We need to figure out how to add things to our load path. So let's figure out how to do that. I'm going to copy these out. Let's say Lua. Require path. Load files. Require function on a full path name. Configuring path settings. We want to say, hey, when I require a thing, a common problem with Lua newbies is the setup of Lua environment. Lua allows you to load external libraries to prevent you from having to type exact system path. It uses library paths to automatically look them up. So it's looking in particular places to go, hey, if I say I want a thing, it'll go like, oh, I know where to look for the thing. And that's pretty cool. So here's how it goes about doing that. Each search location in the path is separated by a semicolon, and a question mark indicates the name of the module. So An example Lua path could look like this. Lua path equals user local Lua !Lua. So if I say socket, then it's going to look for a file called user local Lua socket.lua or modules.lua. Verb just as an example. In Lua, if a package consists of multiple modules, they are usually organized in a tree structure when requiring a module in this tree. We're not super worried about that just yet. So how do we update that path, though? Let's see, manipulating Lua. What if you want to change paths from inside Lua? I totally do. Package.path is available, so we should be able to look at... Okay, so insert this line to see what paths are being searched. Let's print out package.path, right? I'm going to go ahead and suspend here, and we'll run Lua. And we'll say print package.path. There we go. Here we can see all of the places that it is looking for our Lua files. And that is just fine by us, I guess. Cool. But it's not looking in the directory that we have our Android file. So that would be why it's encountering some issues. Let's go ahead and jump back into our file. Let's update this, I guess. Package path, package.path equals package.path semicolon. And I guess we need to give it the full path. Can I get the current... we need to append... Let's see, what is cpath? I don't care what cpath is. I want to get the current working directory. I want to get the current directory. Let's see. Lua, current working... Or let's see. Current file directory. Directory of current file. That's what I want. Because I want to basically say, actually, I don't care where I'm running this from. I want to say the current folder up one and then into src. Current file. Let's see, Lua file directory. Get file directory. Yes, this. Get containing path of the Lua file. Yes. Lua script is only being run. Try arg0. Good path. Debug, get info, source. Whoa, my gosh, this is confusing. Lua is very confusing, I must say. Okay, so instead of doing all of this, let's, I guess, because the error messages are getting tricky, I'm going to go ahead and move this down here. We're going to mess around with this. We're going to figure this out. So script path here's a function that they came up with to get a script path. Let's see if that happens to work. We'll go ahead and just blatantly steal that. Whoops. All right, we copied a little too much, but that's all right. Yeah, so that right now, that's fine. We're manipulating our package path, but that's okay. Let's run this. It should print, whoops. What just happened? Let's run this. All right. No file, android.so. That's fine, okay. But packaged, okay, so it's getting this, but it's not getting the full directory. It's not getting, arg0. The dot file with the original, what this get? Then try arg0. Okay, let's try arg0, I guess. Let's print out arg0 and just see if that gives us what we want. What I want is basically I don't want to have to hard code the directory that this is in, because what if that changes? I want to say, hey, I want to be from right here and up a little bit. This gives me not the full path. So, not super happy about that. Arg0 seems to work, but it's not doing the full path. Current dir, hang on. Place .file with your own version of this function. Debug to info because it returns the string path .file. Relative path. Okay. Create to file is relative path. Then path file is current dir. Aha, current dir. Can we print current dir? Print. Current dir. No such thing. All right, where's current dir then? Where are they getting current dir? Create to file, arg to file is relative path. Oh, no idea where that's coming from. Look at the debug library. Let's see. arg0 match, blah, blah, blah. Okay. Lua. Current file. Absolute path. There we go. Sure. A global thing. Something like Python's file. So the reason to do this is that you want to have, let's see, debug get info 1s. Oh, maybe. Let's see if that does it. Print debug info. No, debug.getInfo. 1s. No, that was not right at all. Local inflow is that. Oh, dot source. Dot source. Nope. That is not helpful at all. All right. So beginning with an at file. Passing 1. Well, this is frustrating. Alrighty. Well, let's see if we can just update the Lua path. Require relative path. Load files by relative path. Lua is, I gotta say, pretty darn complicated and unfun. So, okay. Let's say package path. /mylib.lua. Package path. Maybe? Let's steal this and see if that happens to work. Whoops. Still, let's see if we can figure out exactly what it is that this is doing. All right, we'll paste that in first. We'll obviously paste it first and then try and figure it out. Oh, hang on. No, this actually makes sense. src. So we're saying, yeah, this current, well, not the current directory, but up a directory. No. Let's see if that. Oh, look at that. It works. That fixes the problem. Okay. Now, this is totally not going to work in some situations. Let me explain why. So, what we're saying is add src !Lua, which is fine because we're running this in this current directory. But if I happen to go into test, now I'm in test, and there's Android test, and I try and run Android test, or I say Lua Android test, it's going to get angry because it's going, hey, I can't find it because it's looking for src in this folder. So, okay, I'm not happy about that. Lua is a terrible language and should be taken out back and shot. But, you know, for now it's fine. All right. Anyway, I guess one other thing that we could do, I don't like having, so this is the file that is responsible for testing our Android package. I don't like the fact that this whole test library, the library that we're using to define what testing even is, exists here. I want that to, that is a thing on its own. So I think that should also go into here. We're going to call test.lua. This is its own thing. We're going to make that a module as well, and we'll import it into our Android test. And because we've already said, hey, look in this directory whenever you're trying to find things, and we're all good. Now, of course, this doesn't mean we do need to have this one line at the top of every single test that we write in the future, but hey, you win some, you hate some more. So it's fine. All right. Let's do that. Let's see. Now we don't have test here, so we'll replace that with local test equals require test. And of course, this is going to fail. Boolean value, blah, blah, blah. It's getting confused about something. Yeah, it's mad about this there. Now, it's not getting the value back because we're not exporting it because we haven't set this up to be like a module. Local test equals this. We need to just return test. I think that should be it. There we go. Okay. Our stuff passes again. Now we've got things split up into multiple files. That should make it a little bit cleaner. So there's our Android. It now works as, it's now a module, and it only has code related to doing the stuff that it's supposed to do. Our test file, its only job is to do test stuff, and Android, its only job is to do the Android stuff. So that's good, I guess. Now, one thing that we could also worry about if we wanted to is we could say, hey, what this is going to mean is that if we try and require Android and we've not defined what robot is and we try and call Android functions, it's going to get all sorts of confused and angry about us, or angry about that. But that's fine. We can always just say, actually, I want to try something. Local robot. I want to just make sure this still passes. Nope. Now it gets angry. Okay. So the reason for this is that Android implicitly requires the robot module. Now, the robot module is something that we didn't write. It's something that we're loading that does all the Minecraft-y type of stuff for us. So I think we'll just leave this for now. What this means is that when we're writing an actual script, we'll have to say local Android, or we'll have to say robot equals require robot before we require Android, and we can't also let it just be a local robot. We have to make sure that it's a global variable. Otherwise, the Android libraries are going to get all sorts confused. That's maybe something we can fix in the future when we figure out how to better stub things out. But hey, alrighty. let's get back to the actual code. So what do we want to actually have happen? Android.move is supposed to call robot functions, and it does do that. This is a terrible way of testing it, because if we change this, string, I'm going to say Android.move backward, the test still passes. And the fact that we're passing it this argument at all doesn't seem to matter whatsoever. So let's go ahead and say test Android move calls. Let's see. Let's see. Calls. I don't know. Let's just try and let's see. Yeah. Let's try and figure this out. Android move calls functions in sequence. So what I want to test and end. There's our test. And what I want to test here is actually, we can go ahead and we'll make this part of just kind of standard setup stuff. Say robot is that. Not super proud of that, but it's okay. What I want to test is that when we call Android.move, forward, left, right, back, those being, well, and up and down. I want to verify that when we do that, I want to say calls made. I want to assert calls made equals FLR BUD. We want to make sure that it's not just, oh, it happened to call forward, or it happened to call these things in the right order. I want to make sure that when we say, hey, go in these directions, it goes in those directions in the correct order. So let's go ahead and run this, and it fails, which is good. It fails on line 11. Of course, that could be for any number of reasons, because we don't have great error messaging, but that's okay. We'll go ahead and say local calls made equals an empty string. And it's still going to fail. That's fine. What we need to do is we need to set up, first off, a way for calls made to change. So we're going to say function robot forward. It's going to be calls made equals calls made ... f. So we want to say, hey, if somebody called forward, then go ahead and add an f to the things that happened. Robot.back will be a b. And we'll just paste this 4 more times or whatever. Oh man, that was dumb on my part. All right, robot dot, what is it, left or is it turn left? Let's jump over to Minecraft, because Minecraft is probably feeling pretty neglected. Oh gosh, okay, my computer's being weird. Let's take a look. Minecraft, how are you doing? All right, Vinny, what's up? Let's quit this, and we'll run Lua. We'll say robot dot turn left. Is it left? Okay, so it's turn left. Turn right. There we go. Good. Thank you. That'll be all, Vinny. That's all you are needed for. I appreciate you being available. So robot.turn left should make the call L. Robot.turn right should make the call R. And I believe actually assert will accept 2 different arguments. It'll accept a string, so something broke. Let's see if that'll work, if we get that error. Good. Now we get a custom error. We can actually give ourselves an error message that'll be a little bit more helpful. We'll say expected we can say expected FLR. Let's say no, expected ... calls made to equal FLR BUD. Now, if we look, we can see expected F to equal FLR BUD. So we can see, hey, that's what's going wrong. So turn left, turn right, up, we'll add a U, and down, we'll do this. There we go. So we go ahead and run this. Now we have a bit of a problem. We can see, okay, well, L is not working. So we've got to figure out what's up with Flurbud. Well, the reason for that is that there's no such, the move just calls robot.forward. So, all right, well, you know what we should do. What's the easiest way that we can make this test pass? Turn left. Or at least this will get us closer to having it working. Expected FL to equal FLR BUD. Well, that's fine. Whoops. Oh, gosh. Okay. Left. Turn right, and Flurbud, so back, and then up and down. Up, And hooray, now our stuff passes. Except, wait, it's tried to call nil value. What? Robot.turnLeft. Aha, now we have an issue. Now we have another issue. Here's a fun issue. Our first test now fails. Not the second one. Android move calls robot functions fails because it's going to try and do all those things, and those aren't defined as part of our stub, which is frustrating. So now we see that something fails, and we need to try and figure out how to fix it. Well, really, turn right shouldn't even be called, right? Because the message doesn't tell it to. Let's go ahead and say this takes a let's say it takes a path, and we'll say if path. I don't know if that's going to work. That may work. We'll see. Why is that? That's not liking things. Then oh right, if path then. There we go. We'll see if that works. Let's run. Nope. Still not happy about that. So path still is value. Still exists. Even if we don't give it an argument. Oh no, we did give it a path. I take that back. All right. So now we actually have to. There's no way for us to like hack this to make it just barely work without actually starting to write the real code. So let's go ahead and say path. Actually, what I want to do first is I want to go ahead and open us up a Lua. Let me make the font size here larger. Lua. Let's go ahead and try a thing. So FBL. That'll be our string. S equals that. Can we do f.split? Split on an empty string. S. Okay, s.split. Can I tab complete? No, I cannot. Equals s. Okay, that'll tell us what it is. Let's figure out how to split a string in Lua. Lua, string split. Whoops. There we go. Yes. There we go. Split join, blah, blah, blah. Cool. Concat, blah, 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 blah. Splitting strings. Gmatch. Each of those. Aha. So we can just give it a pattern on which to split. So, okay, that works. We don't need to convert it into an array, do we? Really, let's just verify that this does what I think it does. We're going to go ahead and pop this whole thing back open. All right, we've got Lua. Yep, Lua. Yeah, can you just go up to the top of the screen? Thank you, Lua. So we have FBL. So we'll say S equals that, and we'll say S.gmatch. Oh no, that it does give us back a thing. Okay, so S.gmatch. String.gmatch. Got it. String exists. Okay, string.gmatch S, and then we'll say, I don't know, any character, because I think this is a regular expression. Any character. Oh, it gives us back a function. Okay, not a list. So we'll say for I in this do print I end. What? No, come on. Oh man. For I in string.gmatch FBL dot do print I end. Okay, that works. String.gmatch does not give us a list of things, but it gives us this function that is loopable. That's an interesting thing. But that's all right. So let's go ahead. Let's implement that. Let's try and see what we can do here. Let's say path dot for step in string.gmatch path and any character do, and then we'll have to put some stuff inside here. Now this is gonna, if we go back to our test. Oh man, I'm splitting things like crazy. We may not be able to stick with this whole large font size thing too long, but now both of these fail. Assertion failed. Though let's try and make the first one pass, because that's the simplest case. It's a really dumb test. We're just saying Android move F should do this. So let's put an if. If step equals F, then robot.forward. Let's see, that should make that one pass. It does. Hooray. All right. Good news for us. And then we can do the same darn thing for the remaining of these, right? So we can take, let's see, if we split this and go to all these things, I should actually be able to just transform. No, probably not. All right. Well, you can go ahead and just copy these. What are there? 5 of them? something like that. Go to the F. B should be back. And L should be turn left. And R should be turn right. And U should be up. And D, whoops, should be down. And good. Now let's go over to our Android test. And we run this, and both of our tests now pass. And not only that, we know that it makes them go, that they all go in the correct order. So that's pretty cool. This test is really long, and I'm not a fan of it. It's something that maybe we can clean up. But hey, it's a start. Also, this test is now pretty much redundant, but I think it was helpful to keep around because it helped us kind of build a slightly better version of the test that we had before. So, the big question right now for me is, let's see here. This, at least in theory, should work. I'm not a huge fan of it, though. What I don't like all of these various if conditions. These could all be if-else conditions, and that could be very nested. Because right now, even if we know that the step is F, we're still going to check and be like, is it B? Is it L? Is it R? Is it U? If we change that to be else, is there else if? Else if, no, probably not. So it'd probably be like else if this, whoops, and then end. But then this one would become an else if, and so on and so forth, and that would become a nightmare. So I want to see, there's generally a better way to do this. I'm going to Lua a switch statement. Now, switch statements can be very, very dangerous. Oh, Lua lacks that. Okay. Rather than a comparison chain like this. Function is Canadian, Z, blah. Okay. Well, that's fine. Oh, wait, we can have a table of functions. Perfect. That's brilliant. A simple version of the switch that can be implemented using a table to map the case value to an action. This is very efficient in Lua since tables are hashed. So this is a way we can say, hey, if you give me the letter, I will tell you what thing you should do. Let's see. Let's do that. Let's say, let's create a table. We'll say steps is a table. And we'll say here, we'll say F is a function that says robot.forward. End. There we go. That's all. Whoops. Yeah, got it. That's all. And just to verify that this still works, we can then say step F. Actually, steps. Step. Whoa, no. Get back over here. I'm still working on you. And we'll go ahead and call that function. So what this should do is, okay, step is F. We're going to say, hey, look up all of the steps that we know about, find the one with a key of F, and just run that function. Let's just see if that test still passes, because if so, then we can, and it still passes. Good. So we can get the other ones fixed up too. That's perfect. Okay, so let's go ahead and just duplicate this 5 times. We'll go ahead and say, so forward, left, forward, back, left, no, right, up, and down. And we just need to change what those functions are. So forward, oh shoot, I changed the thing. Whoops, there we go. All right, forward, this becomes back, this becomes turn left, this becomes turn right, this becomes up, and this becomes down. And now, we don't even care what the response is, because we're just going to say, hey, look it up in the dictionary of all of the things we should do. So now, because we've already set up, here's the definition. If you see an F, go ahead and do this thing. So that's pretty cool. Let's go ahead and see if that works. Let's go ahead and go into our test. And nope, we get an error. What sort of error did we get? Our error is, it's because we don't have commas here. I'm going to go ahead and just do a replace on the end of the line with a comma. There we go. And of course, my pattern masking stuff is going to go all weird. That's fine. And there we go. We're passing again. One last test that I want to try. Actually, I want to go ahead and say, no, I'm going to go ahead. This is going to be a lot of duplicate code. I want to test something though. Something really kind of, actually, no, I don't even need to have most of these stubs anymore. I want to get the last thing that we want to have working. We've got robot forward stubbed. I'm still going to use calls made. I want to just test Android move F3. Actually, no, we'll go ahead and add just one more. We'll set up robot.back, state plus B, I want to say F3 be F3. And I want to assert that that does FFF be FFF. I want to make sure that we can do these things in terms of numbers as well. I want to say I want to go forward 5 squares, and then I want to go back, and then I want to go forward 3 squares, or, well, 3 squares in both cases. We'll say we expected this to equal FFF be FF. F. Right. Okay. Also, looking at the way that we're setting this up, how we've got this custom error message in here, it might not be a terrible idea for us to write a thing, assert equal, that just automatically does that. But that's something that we can definitely look at a future point in time. So if we run this right now, it should fail. It attempts to call a nil value, field question mark. It's confused because we told it, hey, split on every character that you see. And it's going, okay, I'm going to go run the function in my dictionary of moves. It's basically Android has a bunch of dance moves. These are the dance moves it has. And it's looking for the dance move titled 3. And it's very confused. So that's fine. What we want to do is say, hey, go ahead and pattern match on a different type of pattern. Let's go ahead and open a Lua console real quick so that we can test that. Lua, I want to say S equals F3 B F3. We'll say let's say 4i in string.gmatch S dot let's see, do print I, and there we go. It prints out all those individual characters. We actually don't want it to do that anymore. What we want it to do is say an alphanumeric character. So let's see, A to Z, and then it goes F. Whoa, hang on a second. No, that's interesting. Actually, no. I won't say any character, but then also possibly a digit character. That should maybe work. No, that maybe won't work. We'll see. Nope, invalid escape sequence. Let's look at Lua's stuff. Lua G match digit match digit. Oh, okay. So they're not using standard regular expressions. They're using a different type of pattern. This %d. So it's a digit. So here's how they've got stuff set up, I guess. Let's see if we can get it to. Let's see if we can get that pattern to work for us the way that we want. Wait, what is what? Oh, did I leave? I left the. Yeah, I left something running. All right. Let's see if we can do this. D. There we go. F3. So it's only pulling out things like this. Can we make this optional though? We can. All right. Can we make this grab more than one? So here's my other concern. What if the pattern is not F3, be F3? What if instead it's F32? Because then it would only match the first 3, and then it'd be confused. Yep, that does not work, or that does not, what? That's very, yeah. There we go. That's the pattern that we want. We want to say any character, and then 0 or more digit characters after it should get matched into this pattern. So that's what we're going to do. Oops. Yeah, we know we have this open up here. So I'm going to go ahead and copy that pattern. Now that we've got that working, I'm going to say star. And now it's going to try and do those steps. But we don't want it to try and do those steps just yet, because F32 also does not work. So we'll say, can we just get this by index? No, we can't. Let's see. We want to say if step length. Let's see if we can get step length. Let's say step equals 32. F32. That's the step that we're working on. Step.length. Nil. Step.size. String. No, we don't get any sort of autocomplete. All right, Lua. String. Match. Sure. No, string length. We care about the length. String library. String. Table sort. String, lower string, string length. String.len. Aha, okay. So we want to say if string.len step is greater than 1, then we want to do stuff. Else, we can just do the simple thing of looking it up. So we only have to worry about the special case if things are weird, which should mean that the old 2 tests should still work. So if we run this, no, something's broken. I have a bad symbol somewhere. Where's that bad symbol? It's in Android Lua.1. Okay. Get rid of you. Where did I do something bad? Oh, whoops. Haha. Accidentally replaced a thing there. That's fine. Okay. Run this. Okay, so the first 2 tests now still work, and it's now very confused because basically it's going through and we have this if condition, and right now it's saying, hey, I found F3, but it does nothing at all. Actually, let's go ahead and let's make this a little more complicated just to make sure. We'll say F2 be F3, and then we'll just change the pattern that we're expecting. There we go. So that way we're making sure we're not doing anything too crazy. We'll go ahead now. We've actually got to write this. So we have to say string.lower, string.sub, string.byte. Let's see. Lua substring. No, this is not helpful. I want just the details about string sub. Extract a piece of the string. Okay. The last defaults to negative. Oh, okay. So we can just say string sub string. Okay, let's test this. Nope, this one's old. Go away. All right. So string dot sub step 1. Okay, step 2. There we go. That gives us the 32 part. And then we need to get that into a number. So we'll say local num is string dot sub step 2. So we're just getting the number part if there's more than one, and then we got to convert that into a number. So Lua string to int. Convert string to integer. Lua string to int. Yay, Stack Overflow. Like to convert this to 10 the number. So I think there's a 2 number. Oh, there's a 2 number function. Let's double check that works. 2 number string.sub step 2. That does it. Okay, perfect. Then we don't actually need to assign it. We can just go ahead and do this all in one go. So we'll say for I in 2 number string.sub this. That'll be okay. Nope, we need to do here. And now we just need to get that first character. Shoot. How do we get the first character? Lua. First character in string. First character of string. That's all we want. String indexing. How to iterate individual characters. First character, uppercase step. Nope. Substring. Nope. Let's see. A sub 5. Let's see. Write 5 for the 5th. You have to write 5. What? Oh, hang on. Okay, so that. So if we did string that sub step 1. Oh, that does it. Okay, good. So we'll say for the steps string dot sub step 1 to get that. Except that's probably not a good thing. We'll say local direction equals string.sub step 1. So we're not doing it multiple times. And then we'll just say here, steps direction, and do that like that. So there we go. In theory, this should now work. We'll see. It doesn't. Attempted to call a number value, 21. What? 21. For I in 2 number, string sub step 2. Let's print out step and just see what happened there. Invalid syntax error near step. Layer loading module. F2. Okay, we got F2. Good. Okay, well, we'll say local num is string.sub step 2. Yeah, and so we'll say print direct. Let's see, yeah, print direction and print num, so we can figure out what exactly went wrong here. We'll replace this with num. F and 2, and that was fine. 24. Attempt to call a number value. Oh, I think our for loop is wrong. Let's do it. Did we do any better with for? No, we didn't. Do we do anything better here? Oh, right. Yeah, that's not how we do things. For I equals 1, comma, to number. There we go. Okay, I was wrong. I was wrong about how we do loops in Lua. Step 2. Put that thing back in there where it goes. All right. And run. And all 3 of these pass, which means that we now have a library that we can say, hey, android.move forward 3, right, up, down 2, or whatever the case may be, which is something that, of course, Vinny is eager to be using. So, yeah, despite the fact that we basically got to do no Minecraft at all, we are very eager to use this to say, hey, let's go out and chop a tree. Let's get some saplings. Let's get all that shiz. Because, yeah, it'd be nice to expand this house. It'd be nice to start growing some stuff. It'd be nice to have some additional resources. That'd be a lot of fun. And I will see you next time for more of that. Cheers.